inorganic molecule for energy and carbon dioxide for carbon. We'll never get away from this. So autotroph, CO2 for carbon, the chemoautotroph, getting energy from inorganic molecules. Nitrobacter nitrosomas. I'm now going to modify something I told you earlier about nitrogen fixing. About rhizobium and bradyrhizobium, that thing nitrogen fixing. What we want to do here, the rhizobium and bradyrhizobium will take nitrogen from the air and will produce, I don't want that. Will produce ammonium and nitrite. Now the rhizobium and bradyrhizobium do this. So that's that. Rhizobium and bradyrhizobium are doing the true nitrogen fixing, meaning taking it from the air. Taking the nitrogen from the air, but they're converting it into ammonium. It's up there. It's up there on the screen. Into ammonium and nitrite. But there's a second step I did not give you before. The second step is that both of these will be converted into nitrate. And what does that is the Nitrobacter and Nitrosomas. So what we have there is the Nitrobacter Nitrosomas are using ammonium and nitrite for energy. Now what? Yes?
I'm just checking.
Yes. No, they're bacteria. Now keep in mind they're using the ammonium and nitrite for energy. Energy, remember, is electrons. We've said it many times. Energy is electrons. So in using the ammonium and nitrite for energy, they're taking electrons, which means those guys are being oxidized because they're giving up electrons. They're being oxidized, so the NO2 is becoming NO3, and the ammonium just simply loses all the hydrogens completely and becomes nitrate. So once again, it's an energy thing which involves taking electrons. So the whole thing is nitrogen fixing. The whole point of it is to take nitrogen from the air and make nitrate out of it. The plants use nitrate. They're not using nitrite, they're not using ammonia. They're using nitrate. Actual nitrogen fixing, taking it from the air, but it's becoming ammonium and nitrate. Second step is the Nitrobacter nitrosomas converting into nitrate.
Can you repeat that one more time?
What?
Can you repeat that one more time?
Yeah, again, it's a two-step process. The first step is the true nitrogen fixing, is taking the nitrogen out of the air. And in taking it out of the air, it becomes either ammonium or nitrite. And the rhizobium, bradyrhizobium that you've seen before is what's doing that. But like I say, I kind of simplified it before. In reality, it's giving us these two. You need the second step, Nitrobacter nitrosomas, that continues this, converting into nitrate, and the plants use nitrate. So anyhow, chemoautotrophs, the energy is coming from nitrogen compounds. If you remember from before sometime, the main source of energy for inorganic molecules are nitrogen compounds and sulfur compounds. So in this case, nitrogen. Thiobacillus. Thiobacillus. Thio means sulfur. Thio means sulfur. So oxidizes sulfur from H2S. And in oxidizing the sulfur, you're getting SO4, you're getting sulfate. SO4 with a -3 charge. So see, in doing oxidizing, you're taking electrons. You're taking electrons, you're taking energy. Phototrophs, of course, energy from the sun. Now, we've spoken before about the purple and green sulfur bacteria. Now, these guys are photosynthesizers. But if you remember, they are anoxygenic photosynthesizers. They don't produce sulfur. Oh, sorry. They don't produce oxygen. Forget the sulfur. They don't produce oxygen. We talked about those the very first time we spoke about metabolism. So it was a long time ago. Live in deep lakes because they are anaerobic, so they don't want to be too near oxygen. Photosynthetic but anoxygenic. So a reminder, normal photosynthesis, you've seen this before. Normal photosynthesis has this equation. Carbon dioxide plus water produces glucose and oxygen. You've seen it several times. So that's normal, that's oxygenic photosynthesis. Now, of course, I'm sorry, what?
Where do they get the light from?
The sun.
Even despite being so deep in the lake?
It filters through.
Really?
That's a very, very nice question. Yeah, it filters through, yeah. So they cannot be so far below that the light doesn't go, but it will filter down to some level. And you're right, if they're too far down, no sun. You're absolutely right. I might comment, you may not know this, but red with the longer wavelengths goes down the water easier than the short wavelength ones do. So, same thing for ocean living. Okay, so the purple and green sulfur bacteria are using sulfur, specifically H2S, instead of water. So their product will be sulfur. Now, before I gave you the unbalanced equation, I didn't want to get caught up with all this stuff, but this is actually the balanced equation. 12 H2S plus carbon dioxide. See, before I just gave you 6 carbon dioxide, 6 H2S, but 12. Still producing glucose, because that's what photosynthesis does. Converts carbon dioxide into glucose. Again, a reduction pathway. You are producing sulfur, but 12 H2S or 12 sulfurs, but also now you're making water. But it is a little different than what I gave you before. I gave you the simplified version before. This is the whole thing. Now again, stuff like this, you get tons of sulfur going into the atmosphere. Purple and green non-sulfur bacteria, but those guys are not photosynthesizers. But they're still using the sun for light. But here, they're using the organic compounds to reduce the carbon dioxide. So they're still going to reduce carbon dioxide, but it's not photosynthesis. Cyanobacteria. I'm sorry.
Oh no, I had a question that's actually a little off topic. But this, when it goes into the
Bacteria. Aerobic. These guys used to be called blue-green algae. Now it's cyanobacteria. So they do oxygenic photosynthesis, or photosynthetic if I could type better. Oxygenic photosynthesis. They can also fix nitrogen. They can also oxidize sulfur. So they're pretty adaptable, which of course is good for survival. So they are similar to eukaryotic algae, and that's blue-green algae. But the fact that they can fix nitrogen and do the other stuff makes them much more adaptable.
So they're more adaptable than eukaryotic algae?
Yes. They are. They can live in more places.